Hello everyone, let us discuss a very interesting question, and this question is from the partial differential equation part and asked in the GATE 2024. Okay, and here in the question what is given? It is the heat equation. It is given that del U by del T minus 4 times del U by del x square, del square U by del x square is equal to 0, and the x varies from 0 to 1 open interval, and the Dirichlet boundary condition is given, means u of 0t is equal to 0 and u of 1t is equal to 0. At the boundary this value of the solution is 0, and the initial data at time t is equal to 0 is given that u of x0 is equal to sin pi x, and where x varies from 0 to 1, and the energy function is defined in this way: g of t is equal to interval from 0 to 1 gx uxt square dx, and asking whether the function g, energy function g, is decreasing or increasing, or and what is the value of the limit when the time tends to infinity. Means one type of, it is asking the large time behavior of this energy function g. Okay, so before going to prove or check these options a b c d, first we will derive two inequalities. Means in this question our main approach is that without finding the explicit solution u, we will verify all these options. This is the main motive in this video. Means we are not explicitly finding what will be u, but we can verify all these options. This is the beauty of this question. Okay, let us verify, but before going to verify, first I will derive two inequalities. One is called the Poincare inequality and another one is called the Grunwald's inequality. I will prove the Poincare inequality and write the statement of the Grunwald's inequality. By using these two inequalities, we can verify all these four options. This is the beauty of our video. Okay, first I will prove the Poincare inequality. Before going to the statement, first let me derive some calculation from this boundary condition. It is the Dirichlet boundary condition. It is given. Okay, this boundary condition is given, so it is in our hand, this one. Okay, then by using the fundamental theorem of calculus, it can be written in this way: u of xt is equal to derivative, because derivative and integration cancel out, u of xt it will given, and u of 0t, but we know that u of 0t is equal to 0, therefore u of xt is equal to this one, so there is no harm to write this equality. Okay, then we will take the modulus on the both side. Okay, then when the modulus come inside the integral, then there is a inequality sign is coming. This is because integration of f mod is less than equal to integration of modulus of f. This property is used here. Okay, so I think everything is fine up to this point. Now I will apply the Cauchy-Schwarz inequality, where my f is the function 1 and g is my function, this derivative of u with the modulus sign. Then after applying the Cauchy-Schwarz inequality, I will reach to this step. Okay, here this integration value is nothing but 1. I1 wait before applying before calculating the value of this integration, what I am doing here, these quantities are non-negative quantity, 1 square and these are square, and here x is a variable, and previously I have not mentioned here. Okay, here the x belongs to 0 to 1 close interval, or 0 to 1 close interval I am taking. So if I put the highest value 1, then this integration can be bounded by this, and this integration can be bounded by this, because I am taking the upper limit and my integrand is a non-negative quantity, so taking the upper limit is not a harm. Okay, so I reach to this point, and this value is 1. Okay, so it gives equal to 1, it is bounded by 1, or it is equal to 1, and this value is as it is same. Okay, so then I get that uxt is equal to this one. Then I will square on both sides, so I will reach to this point. Okay, then I will take the integration with respect to x, and the right hand side is independent of x. It is a constant quantity, and I will take the integration from 0 to 1. This is a constant quantity, it simply comes out, so integration from 0 to 1 dx, it gives 1. So the right hand side is same, this one. Okay, and this left hand side is this one, and here y is a dummy variable, so we can also put here x because y is a dummy variable. Therefore I will reach to this inequality. Finally I establish this inequality, and this inequality has a nice name. It is called the Poincare inequality. This inequality says that this is nothing but the L2 norm of u, and this is nothing but the L2 norm of the derivative of u. Derivative of u is called the gradient. Means the L2 norm can be bounded by the gradient norm. This is called the Poincare inequality. If you go higher study, then you will you have to study, mainly it is used in the elliptic PD hugely. Okay, so I established this Poincare inequality. It will be used in our subsequent analysis. But before going to our main question, I will state another inequality. It is called the Grunwald's inequality. This is the statement of the Grunwald's inequality. If f is a differentiable function, I forgot to write in, f is a C1 function, and if it satisfies this inequality, then this happens. F of t is less than equal to f of 0 e to the power 0 to t beta s ds. Here beta t is this function. Okay, now we are in a right position to tackle our problem, main problem. In the main problem, gt is defined this one. Okay, then we will take its derivative. This is g dash t with respect to time, and here the derivative side, derivative will be here this side. Okay, then we will take the derivative into the integral, inside the integral, because our u is a differentiable function. It is a one time differentiable with respect to time and two time differentiable with respect to the space variable, but here we are talking about the time variable. So since our function is differentiable, we can take the derivative inside. Okay, after taking the derivative with respect to time, it gives, by using the power formula, it gives 2u of xt. Then by using the chain rule, it gives del u by del t. Okay, but from the equation star, del u by del t is equal to 4 times del square u by del x square. From the main equation here del u by del t is equal to 4 times del square u by del x square. Okay, so we will simply put this value. Then we will apply the integration by parts. Integration by parts means we will shift one derivative to here. Okay, then we will apply the integration by parts, but the boundary terms, this term vanish. Why? Because we have the Dirichlet boundary condition. At the boundary, our function value is 0, so this term vanish, and here del u by del x, and here after integration it gives also del u by del x, so there will be del u by del x whole square, this term, and with a negative sign. Okay, so after simplification it turns out to be that g dash t is equal to this one, and this says that this quantity, it is a whole square quantity, so it is a non-negative quantity. So this implies that g dash t is less than equal to 0. This implies that g is a decreasing function. G is a what function? Decreasing functions. So from this calculation we conclude that g is a decreasing. So option A and B might be true, but we have not verified these limits. But g is increasing, this is false, and g is increasing in the option D, this is also false. Okay, so further we will calculate the limit. This limit can be calculated by our Grunwald's inequality. Okay, so to reach the Grunwald's inequality form, we have reached up to this form. Then we will because this norm is bigger than the L2 norm, but here minus sign is there, so this quantity is less than equal to this quantity by using the Poincare inequality, which we have derived earlier, this inequality. this Poincare inequality. If we take the minus sign, the inequality will be reversed, so that is used here. Okay, so by Poincare inequality we reach to this step, and this function is nothing but gt, so we reached this step. Okay, and after reaching this step I have used this argument that g is decreasing because g is a non-negative function and minus g is here, so g dash is a negative and g is a decreasing function. One can also apply this same argument at this point, which I have applied. Okay, then I reached to the Grunwald's inequality setup. Okay, because g dash t is equal to less than equal to minus g of t, it is looking of this form, f dash t is less than equal to beta times beta t. Here beta t is minus 1, beta t is equal to minus 1. So we will simply apply the Grunwald's inequality to reach this step. Here integration of minus 1 ds, and after integration it gives minus t and g of 0. If we put g of 0, our gt is equal to our g function is this one. This is the g function gt, and here t will equal to 0, so it gives this function. And we know that u of x0, our initial data is sin pi x, so it gives the sin pi x square dx. Okay, sin pi x whole square dx, integral from 0 to 1, and it is a finite quantity, so we call it as number c. It is a constant quantity, it is a finite quantity, and this integration e to the power this gives e to the minus t and e to the minus t. So finally, since we know that our g function is a non-negative function, okay, so finally 0 is gt is greater than 0 and it is less than equal to c times e to the power minus 2, where c is this constant. Okay, then by using the sandwich theorem we will prove that limit t tends to infinity gt is equal to 0, because it is exponentially decreasing. At t tends to infinity it gives the value 0, so we find that the limit of gt is equal to 0. Okay, so let us verify the options. So the option A is correct one. This limit is 1 by 4 is false, so the final correct answer is option A. So the main thing in this video is that we verify all the options without explicitly calculating the value of u, and this type of analysis is mainly done in the analysis of PD. If you go higher study in the PD course, then you will realize the beauty of this analysis of PD. I hope that you all understood it very well. Thank you everyone. See you next time very soon. Okay, bye bye.